Good morning to you all, ladies and gentlemen, my dear brothers and sisters, fine girls and fine guys, and in fact, good morning to everybody. Today is yet another day, and we still continuing our series on sets, that is mathematics for SHS1, and we are dealing with sets and then operations on sets. Yesterday, we started with the introductory aspect of the lesson. Today, we're continuing. But before that, let me set my screen. So mathematics for SHS1. Good. We're looking at operations on sets. Give me some few minutes, I'm coming. Okay. So before we start with the operations on sets, we discussed about the meaning of sets yesterday. We did mention that a set is a well-defined collection of objects. And we see that set is well-defined because the objects or the members of the set are of the same kind, okay? And then we said that the objects of a given set are known as elements or members. We also talked about finite sets, that's types of sets. We talk about finite sets, a set whose first and last element or member is known. We talk about infinite sets, a set whose last member or element is unknown or cannot be determined. We talk about a unit set, a set with only one member, that is a unit set. We talk about null or empty sets. Now an empty set, a set with no element or member. We talk about equal sets, and we did mention that two sets A and B are said to be equal if they have the same element. If they have the same element, then we talk about equivalent sets, and we did mention that two sets A and B are said to be equivalent, okay, if they have equal number of elements. That's equal number of elements. Then we also talked about universal set, that is any set under discussion. Any set under discussion is said to be a universal set, or a set from which other sets can be formed from is a universal set. We also talk about subsets, that subset is part of a universal set, or it is formed from any set under discussion. And then we also learned how to determine the number of subsets that can be formed by a given set, okay, using the formula 2 exponent n. So where n is representing the number of elements, where n is representing the number of elements. So if I have the set A, B, C, and I want to determine the number of subsets that can be formed by the set A, B, C, then we have 1, 2, 3 members, so n is 3. That gives us 2 exponent 3, and that should be equal to 8. So a set with 3 members will form 8 subsets, subsets. We also learn about how to writing down all the subsets that can be formed by a given set, or that can be formed from a given set. Write it down all the subsets, okay, that can be formed from a given set. Then we did mention that every set is a subset on its own. Every set is a subset on its own. And then empty set is a subset of every set. Empty set is a subset of every set. Empty set is a subset of every set. Good. So those are some of the things that we discussed yesterday. And we also learned about how to list the members of a given set. How to list the members of a given set. Okay. So that is a quick recap or a quick review of the introductory aspect of the lesson. Good. Today we are moving on to operations on sets, operations on sets, operations on sets, operations on sets. Okay, good. Now with operations on sets, the first one that we're going to look at is intersection of sets. Intersection of sets, intersection of sets, and that's a symbol for intersection. Intersection of sets, intersection of sets. Okay. Now, when we talk of intersection between two or more sets, not only two sets, it should be two or more sets. When we talk of intersection between two or more sets, okay, we are looking at members that are common to those sets, members that are common to those sets, okay. That will be their intersection, members that are common to those sets. So for example, I'm teaching in, let's say I'm teaching in St. Mary's, okay, and at the same time I'm teaching at, let's say, Madonna, okay, I'm teaching in St. Mary's, and at the same time I'm teaching at Madonna, okay. Now the intersection between Madonna and St. Mary's will be me, okay. I'll be the intersection. I'm common to the two schools. Are we there? So the intersection, whenever they ask to find the intersection between two or more sets, okay, or the intersection of two or more sets, we are looking at the members that are common to the sets given. Members that are common to the sets given will be their intersection, okay. Members that are common to the sets given will be their intersection, will be their intersection. So for example, if I have set P to be equal to 2, 4, 6, 8. And set Q, that should give me 1, 2, 3, 4, 5. Then set R, let's say 4, 8, 12. Good. So if you are being asked to find the intersection between P and Q, P intersection Q. Please mute your audio for me. P intersection Q. Okay, meaning the members that are common to both P and Q. Members that are common to both P and Q. And that will be, we have 2 in P, 2 in Q, 4 in P, and 4 in Q. So that will be 2, 4. That will be 2, 4. So P intersection Q is 2, 4. Is 2, 4. Good. If you are being asked to find P intersection R, P intersection R, members that are in P and at the same time in R, members that are in P and at the same time in R, okay? So P intersection R. We are being asked to find P intersection R. Good. So that will be, we have 4 in P, 4 in R, 8 in P, and 8 in R. So 4, 8. Good. Now we are being asked to find P intersection Q intersection R. P intersection Q intersection R. Okay. P intersection Q intersection R. That is members that are common to both members that are common to P, Q, and R. Okay. Members that are common to P, Q, and R will be their intersection. Automatically have 4 in P, 4 in Q, and 4 in R. So the answer should be 4. So that is how we find the intersection of 2 or more sets. That is how we find the intersection of 2 or more sets. That is how we find the intersection of 2 or more sets. That is how we find the intersection of 2 or more sets. Okay, so that is intersection of sets. Intersection of sets. We look at union of sets. When you see this symbol, that is union. Union. That is union. 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 So we look at union of sets. Union of sets. When you talk of union, okay, it means we combining union. We are combining. Remember, marriage is a union between a man and a woman and whatever. Union. We putting them together. Okay. So the union of 2 or more sets means that we combine all the members of the set given. That's the union of 2 or more sets. Okay. We combine all the members of the set given to get their union to form one whole set. That is union. Good. So if I have let's say a set M to be equal to A, B, C, a set Q is equal to Q R. Okay. Now M union Q. M union Q, that is we combining the members of M and Q. That's the meaning of union. Okay. We combining the members of M and Q. So M union Q should be A, B, C, Q, R. So M union Q should be equal to A, B, C, Q, R. Okay, A, B, C, Q, R. That'll be M union Q. That'll be M union Q. M union Q. M union Q. Good. So union of sets, we combining, okay? Union of sets, we combining all the members of the given sets, okay? All the members of the sets given, we combine them to get one set, to get their union. That is union, we are combining union, we putting them together. That's the meaning of union. We putting them together. That's the meaning of union. Good. Good. We look at what we call this joint set. When we say two or more sets are disjoint, okay, they are disjoint sets, meaning their intersection is an empty set. Okay, their intersection is an empty set. They don't have intersection. Disjoint sets do not intersect. Take note of that. Disjoint sets, okay, do not intersect. They don't have intersection. Their intersection is an empty set. Okay, their intersection is an empty set. They don't have intersection. That's why they are disjoint. They are disjoint. They are disjoint. That's why we say that they are disjoint. Okay, they are disjoint. Very good. Okay, now let's move on. We can never talk about operations on sets without talking about the Venn diagram or without mention of the Venn diagram. We cannot talk about operations on sets, okay, without talking about the Venn diagram, okay, without talking about the Venn diagram. So we look at the Venn diagram concerning two intersecting sets, okay. Now, probably we use a Venn diagram to solve two or three set problems. That is problems concerning sets, okay, with the Venn word, with the Venn diagram, with the Venn diagram. Good. The Venn diagram. So if I have the sets here, if I have two intersecting sets, A and B, and I have, let me name the regions, okay, this to be my region 1, region 2, region 3, and region 4. Please take note of this very, very well. It's very important. We are building the foundations of sets. Before we can be able to enter into three set problems, we need to understand the two sets. Without the understanding or without the concept of the two sets, we cannot solve the three sets, okay? So we need to understand the two sets very well. We need to understand the two sets very well. Good. So if I have my Venn diagram, with two intersecting sets A and B, with two intersecting sets A and B. Okay. Now, let me explain the meaning of the regions. We have region 1, region 2, region 3, region 4. Okay, good. Now let's go on. Sorry, I need to take in water. Okay, if I pick number of A, this means number of elements in A. Now the whole of this circle is representing the element in A, or number of A. So to get number of A, we combine region 1 and region 2 to get the number of elements in A. Take note of that. We combine region 1 and region 2 to get the number of elements in A. Okay, we combine region 1 and region 2 to get that. So number of A is equal to I plus I plus I. Take note, that's number of A. Now, number of B, then automatically, number of B will be this circle. The whole of this circle is giving you number of B. So number of B should be I plus I. Number of B should be I plus I. That should give you number of B, number of B, number of B, number of B. And then number of A only. That is when we take out the, remember this is the intersection. I will be the intersection, okay? A intersection B will be I. A intersection B will be I. Take note of that. A intersection B. A intersection B should give us I. Take note of that. Good. So if I want to determine A only, number of A only, meaning I'm taking out the intersection, and meaning I'm taking out this portion out from it. When I take out the intersection, I'll get those in A only. Okay, when I take out the intersection, I'll get those in A only. So number of A only is equal to I. Number of A only is equal to I. That is when you take out the intersection. When you subtract the intersection from the whole circle, what is left here, okay, will be the number of A only. And the number of B only should be equal to I. So when we take out the intersection, what is left, that's I, is representing number of B only. Number of B only. Number of B only. Now, number of A union B. Number of A union B, meaning we are combining all the members of A and B. Okay, we are combining all the members of A and B. Take note of that. We're combining all the members of A and B. Okay, so number of A union B. A union B, we are combining everything in the circles, in the two circles. We are combining everything within the two circles. Okay, so number of A union B should be equal to I plus I plus I. Okay, number of A union B is I plus I plus I. We combining all the members of A and B. So when you see number of A union B, A union B, A union B concerning two intersecting sets, okay? A union B within the Venn diagram, A union B should be equal to I plus I plus I. And then number of A union B all complement. This means complement. Number of A union B all complement. Number of A union B all complement. Now, when we talk of the complement of a set, okay, let's pick the whole rectangle. The whole rectangle is representing the universal set. The whole rectangle is representing the universal set. Where the circles are the subsets. So A and B are subsets of the universal set U. Okay, A and B are within the rectangle. A and B are within the rectangle. Now, you realize that Ivan, that's region 4, Ivan is part of the universal set. It can be found in the rectangle, but it is neither in A nor B. Ivy can be found in the rectangle. It can be found in the rectangle. That is, it is part of the universal set, okay? It can be found in the rectangle. It is part of the universal set, but it is neither in A nor B. It's neither in A nor B. So we call it complement. It's a complement, okay? So when we combine all the members of A and B, the elements that are not parts are known as the complement. When we put A and B together, okay? When we put A and B together, so when you combine all the members of A and B, when you put A and B together, you realize that IV will not be part, but it is in the universal set. So we call it a complement. So number of A union B, all complement is IV. IV. That is IV. Number of A union B, all complement. That is IV. And then take note that when you have number of U, that's the universal set. So number of U, to get number of U, we add I, meaning we are combining everything in the rectangle. So I plus I plus I plus IV. I plus I plus I plus IV should give us the number of U. We are combining all the members in the universal set. So when we add all the members, we should get what? We should get U. That's the universal set. Okay. Now let's move on. Okay. Now let's move on. We're going to learn how to represent set of numbers. Here, so today we are purposely dealing with the two sets, two intersecting sets. Okay, two intersecting sets. That's what we are purposely dealing with today. But before that, whenever I see these diagrams anywhere, be it objectives or whatever given to you, and you are being asked to describe the shaded region, okay? The shaded region is representing A intersection B. Take note of that. That is A intersection B. If I have this, now this is representing A union B. That is A union B. And if I have this, this is representing A union B or complement, meaning they are part of the universal set, but they are neither in A nor B. That's the meaning. A union B or complement. That's the meaning of that. Good. And then last, please, this is representing disjoint set. disjoint sets, you can see that they are not intersecting. Okay, the circles are not intersecting. So these two sets represent disjoint sets. They don't have any intersection. Okay, that is disjoint sets. Disjoint sets. They don't have any intersection. That is disjoint sets. Okay. Now let's move on. Good. Now we're going to learn how to represent set of numbers, okay, on a Venn diagram. How to present sets of numbers on a Venn diagram. We're going to learn how to do that. Before we can be able to use a Venn diagram to solve two set problems, we need to learn how to present set of numbers on a Venn diagram, okay? We need to know how to present set of numbers on a Venn diagram. Good. So let's take this particular example. If the set P is equal to factors of 12, and okay, let me clean the end, comma, Q is equal to, write it here, Q is equal to, let's say, multiples of 3. Good. A subset of the symbol as the universal set, such that natural numbers between 0 and 10. Good. And you are being asked to list, okay, list the element of P, Q, and then the universal sets, the symbol. Then you are being asked to find So you can put out a question, list the elements of P and Q. That's the first question. Let's list the elements of P and Q. That is the first question. And then the second question, find the intersection of P and Q. Find the intersection of P and Q. And then find the intersection of P and Q. And then represent PQ. Represent PQ and the universal set. That is, and you know the symbol. On a Venn diagram. On a Venn diagram. On a Venn diagram. Good. Now let us look at how to solve a question like this, or how to analyze a question like this. When you are being given this question, okay, you have to first of all go through the question to understand the question. You need to know what the examiner is asking you to do before you be able to tackle the question. So if P is equal to factors of 12, Q is equal to multiples of 3, are subset of the universal set, such that the universal set is equal to natural numbers between 0 and 10. Okay, before you be able to list the element of P and Q, I know people have started listing them already, listing the factors of 12 and the multiples of 3 already. No, but before you be able to do that, there is something that you need to know. Okay, there's a footnote. It said such that, okay, say where P and Q are subsets, P and Q are subsets, P and Q are subsets, and that's the didn't come. Where P and Q are subset of, okay, where P and Q are subset of the universal set, meaning all the members of P and Q that you are going to list should be from the universal set. So before you can be able to list the members of P and Q, you must first of all list the members of the universal set. We have natural numbers between 0 and 10. You know the natural numbers are the counting numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are the natural numbers between 0 and 10. Natural numbers between 0 and 10. Okay, good. P and Q are subsets of the universal set. So P factors of 12, meaning that the factors of 12 in the universal set. So if you list any factor of 12, that is not part of the universal set, is wrong. So we're going to have factors of 12, 1, 2, 3, 6. You won't include 12. If you add 12 to it, it's wrong, because 12 is not part of the universal set. Then Q, multiples of 3, meaning multiples of 3 in the universal set. Multiples of 3 in the universal set. So we have 3, 6, and then 9. 3, 6, and 9. 3, 6, and 9. Good. Now, we want P intersection Q. That is, members that are common to both P and Q will be their intersection. So that will be 3 and 6. Good. Now P union Q. we are combining all the members of P and Q. Okay, we're combining all the members of P and Q to get their union. So P union Q, that will be 1, 2, 3, 6, 9. 1, 2, 3, 6, 9. That will be P union Q. Good. Now, we want P union Q all complement. P union Q all complement. P union Q all complement. So meaning that the members that are in the universal set, okay, members of the universal set that are neither in P nor Q, but they are part of the universal set. They are part of the universal set. But when we combine the elements of P and Q, they are not part. They are neither in P nor Q, but they are part of the universal set. That is P union Q, all complement. That will give us, so we have 4, because 4 is neither in P nor Q. We have 5, we have 7, we have 8. They will be the complement. 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 Good. Now you are being asked to present this on a Venn diagram. And you are being asked to present this on a Venn diagram. When you are being asked to present this on a Venn diagram, okay? So we have your rectangle. You have your two intersecting sets. You name them P, Q. You have the universal set. We first represent the intersection. So P intersection Q, 3 and 6. Okay, and then the members in P only. Now when we take out the intersection, those in P only, it will be left with 1, 2. So when you say the members of P will be 1, 2, 3, and then 6. The whole of this circle. The whole of this circle will be the members of P, represent the number of members in P. So 1, 2, 3, and 6. Now, if you want the members in Q only, that is when we take out the intersection. What is left? That is 9. So the members of Q is 3, 6, 9. But then number of elements in Q only or Q only, members of Q only, that is what? That is 9. And then those who are part of the universal set, but they are neither in P nor Q, okay? They are part of the universal set, but they are neither in P nor Q. They are neither in P nor Q, okay? Good. Those people will be here. So 4, 5, 7, 8. They'll be the complement. That is P union Q, all complement. 4, 5, 7, and 8. Okay. So quickly, we look at the application of Venn diagram, okay, concerning two set problems. That's application on sets. That is when you're being given a word problem, okay, to deal with. Good. So let us look at when you are being given a question of such nature. I'll be typing the question, so give me some time, please. Two newspapers, graphic, and Times are delivered to 40 houses. To 40 houses in Adenta. Each house receives at least one copy. At least one copy of a newspaper. In all, 26 copies in all, comma, 26 copies of graphic and 24 copies of Times are delivered. Find the number of houses which receive Times only. Okay. Two newspapers, graphic and Times, are delivered to 40 houses in Adenta. Each house receives at least one copy of a newspaper. In all, 26 copies of graphic and 24 copies of Times are delivered. Find the number of houses which receive Times only. Good. When you are being given a question like this is a two-set problem. That's a two-set problem. Before you can be able to use the Venn diagram to solve a question like this, okay, it's a word problem. The first thing you're supposed to do is to go through the questions. As you go through the question, you put down the important points. As you go through the question, okay, you write down the important points, the facts that you need to solve the question. You write them down. High quality data from the question given. Okay, and that's how we do that. The two newspapers, Graphic and Times, are delivered to 40 houses in Adenta. Okay, two newspapers, Graphic and Times, are delivered to 40 houses in Adenta. So meaning that the total number of houses that receive the newspapers, okay, that receive the newspapers are 40. So meaning number of you is equal to 40. And each house receives at least one copy of a newspaper. Each house receives at least one copy of a newspaper. So with this, it means that we are not going to have the complement. We have the region 4 people. Okay, we have the complement, we have the region 4 people because each house receives at least one copy of a newspaper. Meaning if that house didn't receive graphic, the house will receive Times. Good. But in all, 26 copies of graphic and 24 copies of Times are delivered. So number of graphic, okay, that were delivered. So we are using capital G to represent the graphic. 26. Number of Times. 24. Good. Now in the question, then you should find the number of houses which receive Times only. Don't target that place yet. We are not done with the information. We are not done with the facts. You see, this is a two-set problem. That is, this question is between two intersecting sets. Okay, this question is between two intersecting sets. So we need to have their intersection. But their intersection wasn't given. That's the number of houses that received both graphic and Times wasn't given. We need the intersection first. So let X represent number of houses that receive both graphic Very good. Let S represent the number of houses that received both graphic and times. Now, is that each house receives at least one copy of a newspaper. So we wouldn't have the region 4. Houses that did not receive any of the newspapers. Okay, houses that did not receive any of the newspapers will be 0. Now we go to our Venn diagram with this data, with this information that we have. We're going to represent this information on the Venn diagram. So number of U, that's the universal set, is 40. You have the 2 intersecting sets. Number of G is 26. Number of T is 24. Now the intersection between G and T, that is this portion, that is X. If I want the number of houses that receive graphic only, this is the intersection. Okay, that's the intersection. So if I want to determine, or if I want the number of houses that receive graphic only, meaning you are subtracting the intersection from the number of houses that receive graphic. Okay, so we subtract X from 26 to get this portion, graphic only. So that will be 26 minus X. If I want the number of houses that receive times only, that's this portion, we subtract the intersection from 24. That will be 24 minus X. Remember, the complement is 0 because each house receives at least one copy of a newspaper. So the complement here is 0. So the complement will not come. Please, the X is not fixed for the intersection. The X is not fixed for the intersection. The variable, okay, depends on the question given. So the position of X will depend on the question given. Sometimes they can give you the value for the intersection. When they give the value for the intersection, take note, you are not going to represent the intersection with X. We rather represent the unknowns with the variables. So take note of this. The variable X is not fixed for the intersection because the intersection wasn't given. That is why we are using S to represent the intersection. So assuming the intersection was given, then you are not going to use S to represent the intersection. S will represent the unknown quantity that wasn't given. So X could be in place of 26, it could be in place of 24, it could be in place of the 26 minus X, it could be the 26 here, it could be the 24 here, it could be the region 4. Anywhere, it could even be the universal set. If that one wasn't given, then that would be X. So the position of X depends on the question given. Good. Now let's move on. Remember, you were given this clue that when we add region 1, that is I, plus region 2, that is II, plus region 3, that is III, plus region 4, we should get number of U. Remember that. You are given number of U is equal to I plus II plus III plus Ivan. Okay, the number of U is 40. So in place of number of U, we write 40. So 40 equal to I. And I is representing 26 minus X. So 26 minus X. I is representing X. So plus X. I is 24 minus X. So plus 24 minus X. Now, Ivan is 0. So that one will not come in. Because each house receives at least one copy of a newspaper. We don't have any house that didn't receive any of the newspapers. Okay, so that portion will not come in. So now let's move on. Minus S plus X is that you have negative 1 plus 1. SHS, you'll be using calculator, so it will be very simple for you. Just enter minus 1 plus 1, and you realize that minus 1 plus 1 is 0. So minus X plus X will cancel, because minus S plus S is 0. So that will cancel. We're going to have 40 to be equal to 26 plus 24 minus X. Okay, and then 26 plus 24, automatically you tell me that is 50. You tell me that is 50. So 40 is equal to 50 minus X. We're solving for X, so we rearrange and group like terms. Okay, we're solving for X, so we rearrange and group like terms. We bring negative X to this part of the equation, that is to the left hand side of the equation, and we bring 40 to the right hand side of the equation. When we bring negative X to the left hand side of the equation, since it is crossing the equal to sign, the sign must change to positive. So we're going to have positive X is equal to, we have our 50. We are bringing 40 to the right hand side of the equation. It is positive. When bring it becomes negative. So minus 40. And then 50 minus 40, that should give you 10. So meaning 10 houses receive both graphic and times. 10 houses, okay, received both graphic and times. That is 10 houses. Now, but the question says that find the number of houses which receive times only. Times only. And remember, times only, that is I, region 3. When we subtract the intersection from 24, we get the number of houses that receive times only. So this is it. Times only is 24 minus S. So number of T only. That is times only is 24 minus S. Mean we are subtracting the intersection from it. Okay, we subtract the intersection from it. So 24 minus X. So we're going to have 24 minus 10, and that'll give you 14. That'll give you 14. So 14 houses received times only. 14 houses received times only. So this is how we solve the question concerning two set problems. The first thing is to go through the question and put down the data. That's the important fact from the question. The important fact will help you to put down a good Venn diagram, and a good Venn diagram will help you to put down a correct equation. The correct equation will yield you a correct result or a correct solution. But please, they can trick you. Take note, if assuming that, let's say, in all, you'll be given the number of houses that receive graphic only. We are being given the only. Let's say 20 houses receive graphic only, 30 houses receive times only. When the question is of that form, you won't subtract the intersection from it. You won't subtract the intersection from it. As we proceed, I'll give similar questions on those areas so that we look at how to go about it. When you are being given such a question, how you're supposed to do it and how you're supposed to go about it. Good. But on this note, we end today's lesson here. We end today's lesson here and continue next time. I wish you all the best of luck. Enjoy the rest of your weekends, meaning your day and then your weekends. Okay, you can chill, but don't freeze. And then you have to put on your nose mask. So the vaccine is out, but you need to protect yourself. If you haven't taken the vaccine, you need to protect yourself from COVID-19. Okay, you stay safe and you stay healthy. We need you alive. We need you alive. We need you alive. Good. I wish you all the best of luck. Till we meet again. Bye bye.